Hi there folks, and welcome to another episode of Michael's 3D World, brought to you by RM3D Creations. We're going to cover a little bit of ground today on some new stuff. I've been now in the 3D printing world for about 2 weeks, and I've learned a lot of things along the way. I've been running this printer that I've purchased, I wouldn't say non-stop, but it's been practically non-stop. I've done a lot of 12-hour prints, 8-hour prints, and some little 2- and 3-hour prints, and have learned some stuff that's some failure points. I've learned some success. I've also started to learn how to design and draw in a program called Fusion 360. I'll show you a little bit of that in this episode. And I've got a couple more modifications I want to put on this Ender 3 version 2, or Ender 3 V2 they call it. If you watched this previous video, you saw the upgrades that I made. Well, there's a couple more small upgrades I want to make, and I know there's some people out there going, why are you making all these upgrades? Is it not good enough right out of the box? And it is. Yeah, actually, I pulled this thing out of the box and I printed with it for 3 or 4 days before I made the upgrades, maybe 5 days, 3 or 4, whatever. But it works great. I mean, I could have printed all my upgrades myself. My son knew I had a printer coming. He went ahead and printed the upgrades ahead of time. Had them ready, so when we came here, we could go ahead and install these. I probably will end up with another printer in the near future because I'm finding that one printer just doesn't feel like enough, because I'll start an 11-hour print and yet I'll design something else and I want to print that. And I'm an impatient person. But let's jump in. I'm going to show you some of the things I got going on, some of the things where I'm at today. And we're going to do these quick upgrades. There's only 2 upgrades I'm going to do on my machine today. One is a camera mount holder. And the other one is I've added a camera. Okay, there's 3 upgrades. Camera mount holder, camera, and springs for the bed. That's what I'm going to do on this video. Plus I'm going to show you some things I'm drawing and designing that have to do with my other channel, which is basically outboard motor repair and marina type stuff. So let's jump in right now. Let's talk a little bit about this print. Now this I got from off of Thingiverse. I'll leave a link down below as to what this is and where you can find it. If you decide to use this, folks, feel free to give those people a tip, because some of the designs are pretty good. And this one here I just printed overnight last night. It just finished up this morning. And I'm getting ready to peel it off the table. Let's see how good it's stuck. Now I've been cleaning my table with just 91% isopropyl alcohol, because when you touch it with your fingers and stuff, you leave your finger oils and that can inhibit the adhesion. Wow, that stuck really good. So good. That's incredible. I've never had them stick that good. Now what I did, that's really good. What I did with this one, there we go, it popped right off, but that held really well. Now, what I did with this print is this is just some PLA from Matter Hackers. And I actually ran it, the temperature range is from 180 to 220 that you run this at for the tip temperature. And I ran, you know what? I need to turn this off. The fan make a little less noise for us. I ran this one at, at 210. I tried running a little hotter temperature to see if I would get a better laydown, better adhesion, and I'm really pretty pleased with how this looks so far. This came out clean, and as you just saw, those things are, yeah, they held down real nice. That's those weren't going to just pop loose, were they? That was pretty cool. Let's see if I can get this one pop off. The parts seem to be really strong. Now you can see under here, this is one of the ones that have some I forget what you call it now, when you put some support material. Duh. I was just about ready to say when you need some support, but it's called support material. We'll peel that off, get that cleaned up. But no, I got a little camera. Here it is. It's a little 1080p camera. I got it off Amazon. I'll leave the link down below on that. It's this guy right here. Nothing fancy at all. Just a little 1080p camera. Hey, it works really well. But what I got it on a little tripod stand here, and what I've noticed is that the picture, and you'll see on the time lapse in some of the video I'll have of this time lapse. It's cool because you can set it in your Octoprint that we've downloaded last time and got installed. That works with that's on our Raspberry Pi, I should say. It does a really good job of doing time lapses, which is really cool, because what it'll do is it'll only do a time lapse picture with every Z move up. So you don't sit here and watch that head sitting here and do this all over the place and watch the part come up. It's actually a better time lapse in my opinion. And I can also show you the thing coming. Who wants to sit here for 11 hours and watch this thing build, right? So you can see it just basically come right out of the table. Wow, that is really crazy stuck. Almost too good. This had a, wow-wee. I gotta get that off of there somehow. Let's pull this off of here so I don't mess with my table too terribly much. I gotta pull it off anyway. Let's see if I can get those knocked off. Okay, I got these broke loose. I had to take this table off and I set it up edgewise on my bench. And I took the putty knife and I kind of hammered down on them a little bit here and got them pop free. They held extremely well, which shocks me. It's good stuff though, it's good stuff. You want it to hold on that good. Like I said, I had the nozzle temp at 210, which I'm pretty happy with that. The bed temp was at 60. And maybe I should have, and this is in Celsius, folks, and maybe I should have done a 50-degree bed temp. Anyway, I'm playing around with different things, but yeah, I've been had a little trouble with some adhesion here and there, but definitely not this go around. I did not, so it's pretty cool. Anyway, we got a couple camera mount pieces here. This is one that will mount to the bed, you know, to the 80-20, the extrusion, aluminum extrusion, and then we'll start putting these guys in here. Will be the articulating arms that can go like this. You kind of see how things are going. And then we can mount this, and I can get this camera angle, because right now, this camera angle being down what it is right now, pointing down at the table, I seem to get with this light I got directly above, I get a lot of washout on these bright colors. So I'm going to take this camera and I want to mount it so it's up a little higher, but something that's locked in. But yet, via this, it's still adjustable. So I'm going to go ahead and try putting this together. It has a top piece here that has a thread that you can put in here for screwing your camera. Most of these have like a 1/4-20 mount underneath here. So we can mount this camera on there, and we got some adjustability. So I'm going to put that together real quick and make sure it works. And if it does work, I'll share that with you. If not, I'm cutting this part out of the video. Now this print is designed for a 5mm bolt and nut. I went to my local hardware store yesterday. They didn't have any metric, and I didn't want to drive another 30 miles to get exactly what I needed. So I did a quick conversion with a caliper there at the store and found out that these number 10, I think they're 1024 by 1 inch long, will fit through the hole. The bad part is the nut doesn't fit in the hole that's already there, which is not a big deal. Chances are I'm going to make another one of these, and I might bring these STL files into my Fusion 360 and just make that hex a little bit bigger so it will work next time. But it seems to, I mean, you can assemble it still. It's not a big deal. These also have like a little cable management little notch in them. I kind of appreciate that. But yeah, we'll just, the 1024 seem to fit actually through the hole and everything really nice. Throw that bad boy together like that. You can make this as long or as short as you want, and it seems to have pretty good friction once you tighten it together, that this, you know, will hold whatever you want it to do. And if you need it just a little tighter, you just snug it up a little more. So anyway, let's finish putting this together. One of the other modifications we're going to do to this is we're going to put some heavier duty springs on this. These springs are kind of light, and they'll allow, you know, the table, people don't realize that when the table heats up, cools down, heats up, cools down, things are moving. Now I have seen where people print new knobs and put nylock nuts on here. These are there will be a nylon locking nut to help prevent things from moving, but it's easy enough just to replace the spring. You just back the nut the knob all the way off. Take this spring out here, just slide it out, and put your new spring in. And it would appear to make it easier to go ahead and back. Yeah, do that. Back all your springs off. And you can just do this one at a time. Back them all the way off, pretty much, not till the handle falls off, but you know, pretty close. That's what I'm doing here on the rest of these. Now it should be easier to get this slid right up under here. Oh yeah, much better. Then you just drop your screw back down through there. And then put your handle back on. So we'll go ahead and do that to the rest of them. Easy peasy. All right, we got all the new little die springs underneath here. They're like miniature die springs is what they look like to me from my toolmaker background. But what I ended up doing on this one, this has a little plastic piece underneath here that the spring sits in a little cup. I found it easier just to go ahead and cut this zip tie, pop this little cap off, and then you can actually take all the bolts off the table, these handles off the whole table, and lift the whole table up and set it back down in there. That was actually quite a bit easier. Maybe on some of the other models, I know this is the Ender 3 V2, and it may not have this kind of choke strap on your harness for the back, and it may make it easier. You can do it one spring at a time like I did the front too, but looking back on it now, I would say go ahead and wind them all off and cut this loose, and then you can actually deal with it a little bit easier. You may not have to cut this off to do it, but I did. You guys make your own judgment call there. Anyway, we got all the new springs in. What we'll have to do next is level the bed back up again. Here's just a straight up comparison of the two springs. These here are just a touch, no, they're a touch taller, not much though, but they definitely are substantially stiffer, but not to the point of being too stiff. The other nice thing, the feature they have is, these springs are flat on the end, whereas your regular is kind of round. It sits pretty flat on the end, but not as flat as this style. This is a whole different design. Anyway, I'm not going to throw my springs away. I'll hang on to them. You never know what other project might need them. Anyway, that's the difference in the springs. All right, I pulled the front cover off of this and the back cover where I'm going to mount this. So this is going to be where this guy mounts, right? Well, it works out that these holes that are in here are perfect for tapping to a 1024 screw. So I'm going to go ahead and put a 1024 tap in there so I can bolt this in place. Pretty cool, huh? Alrighty, and just be gentle. I put a little WD-40 for some tapping lube in here, and I'm going to tap them the rest away, and then take an air hose and blow it out, and I'll be ready to mount my part. I'm pretty happy how that mounts on there. That's a nice solid mount, no doubt. The only thing I'd like to have is more of these elbows like this, that I can actually make these turns this way. Yeah, you can string these all together and you can make this loop like this, but by putting this extra joint in here, you can get more articulation out of it. Bad thing is, the one that was in the model doesn't fit. As you can see, I had to sand this away. So what I'm going to do is go ahead and design my own. I can copy most of this one. I can put the same radius that is on this end right here, so I can copy that exactly, and then I'll put this piece, this design on the other end, because that obviously works. And then I'm gonna make a couple, 3 or 4 more of these, and then I can call this arm complete. But as you can see, I just put my new springs on, and I've got things taken apart right now. But it's going to be real easy for me to go ahead and throw my glass back on now that I got my springs in. We're going to re-level the bed. I'll walk through that with you real quick again on how I level the bed. That's not, everybody has different ways of doing it. They also have laser touch-offs. They have micro switch touch-offs. Mine's very manual, but that's where I'm at right now in the stage of my development. So we're going to go ahead and put the glass back on, put the machine back in place, plug it in, and then we'll make my other camera mount pieces. And then we'll assemble that in place and do a video with the camera in the position I want it in and show you how it looks like assembled. Now what I did here, like I said, this was a 1024 by 1 inch long screws I'm using here with 1024 nuts. The other thing I'm going to do is that hex that's in there, that's kind of hard to see. There's a hex in here that the nut is supposed to sit into. This was designed for a 5mm. I'm going to go ahead and put the big enough hex to hold mine in here. And who knows, eventually I may just redesign these arms myself so they hold my standard bolts, because that's what I got at my local hardware store. So those are 1024 by 1 inch long. The original Thingiverse design is for a 5mm by 18 to 20mm long, and the matching nut to go along with it. Anyway, let's get this back on the table and set up and dialed in. Get this bed leveled again and get designing. Let's design something real quick. All right, now that we've got the machine back in its location and turned on, we're going to go ahead and go here to prepare, and we're going to go auto home. And I'm letting it go to auto home without the glass on it because I'm not sure where the nozzle is going to hit here yet. So let's see where it ends up, if we've got clearance or not. See right there, that glass is definitely thicker than that. So what I'm going to do is screw these adjustment knob down so it gives me enough room to put this glass on. I'm going to set you down while I make that happen. I'm going to go ahead and go to the disable stepper so I can move this around easily, and we'll see if the glass will fit underneath there. Glass, build plate, whatever you guys want to call it. See, it's still not quite enough. The other thing I want to do is make sure our table is clean of any debris. I want to go ahead and clean the back of my glass off with some alcohol. This way there's nothing causing any problem with thermal transfer. I need some, when you have that table heat to transfer in beautifully. When you slide this on, you should feel nothing but smoothness. If you don't feel smoothness, you ain't done it right. We're going to reinstall our clips to hold the build plate in place. Now that we've got this where we can move it all around and it's not hitting anything, it's not hitting the nozzle tip at all, or tool tip, or whatever you guys prefer to call it. Now I'm going to rehome it again. And this is going to be a rough leveling. I'm going to do it while it's cold, rough level it. Then I'm going to heat the bed up to 50 degrees C, and we'll re-level it again. So I auto-homed it. I'm going to go back and disable my steppers. I'm going to move it in just a little bit. And if you move it in to where it's just on top of those, approximately where the top of these screws are, you can see a little black circle there. And then you can start, you want to get this thing to where the paper just has some tension on it. Get there. You're going to go over here over that screw, back it off. You see what I'm doing here with the paper? I'm wiggling it, and I'm backing this adjuster knob off so it's letting the table come up. And I cranked that one down a little bit further. There we go. You just start feeling it. There we go. And your typical 20-pound paper is about 3/1000 thick, so that's what gap you're generating there. Now we're going to come to the back corner, about the same spot, do the same thing. We're going to back that knob off until we feel a slight drag. There, we're feeling a drag right there. Now move this across. When you're moving it, don't move it up or down, just push straight across, and then we can back this one off until we get the same thing. There we go. A little bit of drag there. Let's go back to the front. Recheck the front here. As you can see, that one's just a little too tight. So we're going to drop that table back down a little bit. There we go. We're getting close right there. A nice drag there. We're going to do this. Repeat that process, all four corners, until you have all four of them feeling exactly the same. I'm going to go ahead and go over here in the menu, and I'm going to hit the preheat PLA. And that's going to take the bed up to 60 and the nozzle up to 200. I'm actually going to change this here. I'm going to take the bed back down to 50 and go by that. Alright. And then I'll rehome it. Now that my bed's up to temp, I'm going to auto home it one more time. Now that it's home, I'm going to go back and disable stepper, move back to over the top of my screws, and we're going to check that. See, that gap has changed because with heat and the coefficient of expansion of materials, you will have this will actually move on you. So we're going to go ahead and readjust now. And I got a fresh piece of paper here, and you're going to find out that some of that PLA will be trying to come out of the nozzle, and it'll make your paper get a little dirty, so that's why I grab a fresh piece. Come over to this corner. Let's do some double checking here. Quite a bit of movement. I bet I'm moving this this one here close to a half a turn. That's quite a bit. Same here. As you can see, I'm moving that quite a bit. So it just, and that's why you want to do everything at temp. Because guess what? That's what you're operating in. That's what you're going to be printing in, is at temp. You're not printing cold. And so far, it's been worth almost a half a turn to get this back where I want it. So that's why we did a rough beforehand, and then we're doing a final level with it at temp. I'm still going to run across this several times to get it dialed in just where I want it. I know we're spending a lot of time on bed leveling in this video, folks, and I'll give you a little I'll give you a time frame. If you want to skip ahead, you can. But if those of you that are wanting to learn how to do it, this is why I'm taking my time to do it, so you guys can see. It's not a painstaking process, but I tell you what, to ensure your prints come out the way you want, it's just one of those necessary evils. Now, one of these days I may upgrade to the auto touch off, but I'm not there yet. When I do get there, I'll bring you folks right along with me. Alright, I think we're just about there. That one's good. Oh yeah, there we go. Oh yeah, perfect. Let's check that back one more time. Oh yeah, perfect. Now that we got everything, the bed leveled out real beautifully, let's go ahead and do a light cleaning on here with some alcohol, denatured alcohol. Isopropyl alcohol is what I'm using here. Isopropyl alcohol. We'll make sure this bed's good and clean before we start our next print. And I'll go ahead and auto home it again. We're ready to rock and roll. Alright folks, we're going to reverse engineer this piece that doesn't fit. We know this is not the right size. It won't let it wrap around the radius on these little arms here that I'm created without sanding it like I did. I don't want that, so I'm redesigning this part. I'm going to reverse engineer it and come up with my own to work with my standard bolts that are 1024 bolt and nut combination. So first thing we're going to do is select our sketch mode. We're going to select a plane to work in, and we're going to draw a shape. So I'm going to go in here and let's go ahead and zoom on up here because my stuff I'm drawing is fairly small. We're going to go up here, just sketch you a vertical line, then click with your left mouse button, click and hold. Click your other, you create an arc that way. Come down here, second line, and then let's close this gap. We're going to go ahead and put some dimensions on this. We know that this dimension is supposed to be 6.5. We know from the center here to the bottom is 8.5 by my sketch. And we're going to create a circle in the middle here, which we know is 5.5. But with that being done, we've got this part of our sketch done. We're going to create another sketch now, because there's another shape right below it that I'm going to go over here. Now the cool part is when you click into your sketch mode, you can kind of come hover here, and when you come over, see that dotted line? That's what it's going to draw it parallel to that for you. And then you just come down here, come down here, come down here, and see it'll snap to 90 degrees, and it also draws this other line. And then you can come back over to here. And just like that, you've drawn a rectangle. Now we can constrain this with some dimensions. So from here to here, we know is 2.1. We also know that we can make this 17.2. And we can make the height 21.2. Now we've got it drawn in the way we want. In this section, we now have an area we want to do another sketch inside of. That's going to be a cutaway sketch, which is yet another rectangle. And I'm just doing a rectangle, a 2-point rectangle like this, just to make life easy. Then I can actually dimension this one, because I know that I want this to be 15.3, and I want the width here to here to be 8.7, and I know that this needs to be 4.2 from here to here. Now I've got my rough shape drawn to do to create a lot of my solids from. So we're going to finish sketch here. We're going to go ahead and grab that, create a solid, and equidistance from both sides. So we got our distance here. We got to select this as one side right now. We're going to go two sides. So the nice thing about two sides, it automatically tells you both sides, because you can have it two different sizes, two different directions. Now I know I want this thickness to be 8.9, which is 4.45 each way. 4.45 and 4.45. And you're going to create body and you hit OK. Now we can turn our sketches back on. Whoops. Let's see here. I also want to create a body here. So I'm going to create a body there as well. And it's going to be two sides. Let me go ahead and roll this around for you so you can see what we're creating here. Get an idea. It's going to be two sides. Go back to there you go. Two sides. And it's going to throw the same two dimensions up. Now this one is actually a little bit thicker. This is 17.2 overall. So we're going to do that divided by 2. 17.2 divided by 2 is 8.6. So we're going to put 8.6 in here. And you see that went one way, and we're going to do 8.6 in the other one, and that goes the other way. So there's the size of part. Now, the one thing you can see here is our part. This geometry wasn't collinear, so we want to fix that. We're going to add some more shape to this, because I don't like how blocky looking it is. Do you? I don't. So we're going to go ahead and put some fillets in here. I want to pick that corner there. And I'm going to hold the shift key down and pick this corner here. And we're going to make these like 3mm, I think. You can type in 3 and see what it looks like. And if you're happy with that, it's okay. And also I don't like how this is all sharp. Let's make that more fluid as well. I know what my printer can handle there. Let's go back and create some fillets here, just to look more proportionate to what I wanted. So we're going to select that one. That one, that one, and that one, and we're going to make them 6.5s. That looks better. We'll buy that. Locking it in. Now the cool part is, see, we got our basic shape of what we want. We got basically it's going to make our 90 degree. Now we need to put a hole through both sides of this, right? So let's go ahead and do a sketch here. Flip that around. Now we can draw a circle, and if you kind of highlight there, it'll pick your center for you. See when that circle shows up? That's your center. We need a 5.5 hole, and then I need to create a polygon.
So we're going to create polygon edge. Okay, this is going to be the fastest way to create a hex where I want it. Polygon, inscribed polygon. And the cool part is I can come over here and it snaps onto my center of my circle. I can drag it out to whatever I want. I can kind of orientate it a little bit if I want, because it's six-sided. It's showing 6 right now. Do I want it oriented that way? Sure, why not? Now the cool part is it just drew it to a specific size, but I want to actually make it a dimensional size across this flat here, and I want it to be 9.5. Now I've got what I want there. Sweet. We're going to call that a finished sketch there. We're going to do 2 cuts now. I'm going to rotate this around so you can see what I'm doing. I can select this one, and I want to go down through the bottom, so I can drag this down until it snaps onto that, and it's showing over here it's creating a cut, one-sided. Hit OK, and I have a hole. Now I want to see my sketch here that I have of this. I can grab that sketch, and I'm going to do a cut here. Shows the arrow going up. I want this to be 3 millimeters deep. So I'm going to come over here and type in -3. And just like that, you've got your hex created. Isn't that slick? That is so slick. What we're going to do over here is I need another through hole over here. Now I could have taken this other cut and I could have gone through both bodies. Let's just go ahead and do that right now. So I can go in here, this extrusion right here. Let's see here. I think I can edit it. Edit feature on that one. I'm going to roll this around a little bit more. Yeah, like that. Then I can grab this arrow and go right down through there. Hit OK. Now I got a hole through both. So as you can see, there's multiple ways to do this. Now we got our part designed. Whoop, it didn't go through. Whoop, whoop. It didn't go through. Let's go and edit it again. That's easy enough. Edit feature. We'll just drag that arrow. Whoops. I just drag it down to it. I didn't drag it down through it. Let's go back here and we'll just grab that arrow and just come on through. Hit OK. Now we got a hole all the way through this bad boy. There we go. That's the part I want to print right there. I think we got it, guys. Now I want to export it for 3D printing, so I'm going to go ahead and go File, Export, and I'm going to export it as an STL file. And it's going to be called that. It's going to export. And you can see this pop up, and we're going to have this menu come across here until it's full. Once that's full, then I can bring it up in my Cura print program, or Octoprint program. No, I can't. I'm going to bring it up in Multimaker Cura. And then we're going to slice it, and then we'll bring it over to the printer and print it. So you see the progress bar here. Alrighty, now it shows it's complete. We can close this out. I'm going to go ahead and minimize this screen, and we're going to bring in the Cura, just like that. And I'm going to go File, New Project. It clears my bed. That's what we got going on there. We're going to go File, Open Recent File. We're going to see that one I just did. Boom, it's right there. I've got my bed temperature at 50. My print temperature, I want to bump that up to 210. That seems to work really good. And we're ready to build. We're going to hit slice. That's going to slice it. Cool part, it tells me it's taking me about 45 minutes to build and about 3 grams of material. We're going to save to the file. I'm going to go ahead and hit save. Next thing I can do is I can come over here and go upload into my Octoprint. We're going to come in here and upload. Was it 230? This one was it. This is the one I want. I need to delete that one. So we're going to open that one up. I already had my bed temperatures up and everything's ready to go. Had that warming up while I was doing that process. Now I can hit print here, and we're going to let it print. Well, what I decided to do, folks, is I took as you can see here, I've got the other arm that I printed off with one of my own pieces here, and I decided I was going to go ahead and just model up the rest of it, and I'm going to print the whole kit right here. So we'll see what that looks like in the morning. But anyway, I needed multiple arms anyway because I did drill and tap the front of this aluminum extrusion as well, so I can put another mount on the front because I'm going to eventually put an LED light up here so I can have a constant light that's on it. So no matter whether I turn my lights on and off in my room, this light will be constant and I can get some good time lapse for you there. So that's off and running. So yeah, we've got the new springs in, we've got the new arm on, and we've got the camera hanging off of it right here. And what you can see over here, let me show you. Plus, on my mobile device, I can watch it there as well. So when I wake up in the middle of the night for whatever reason, and I want to take a look at it and see how things are going, I can actually start, stop, pause, and do everything from here as well, as long as I'm tied into my network. Pretty cool, huh? Well, folks, I hope you found that informative and helpful. This is the third video since I've started this channel. I appreciate you if you hit the thumbs up if you like what you see, and subscribe if you haven't subscribed already. Spoiler alert, got some poke parts I'm going to be working on next. This is an old water inlet off a Johnson 35 horse. This is my newly designed part. We're going to go over that next go round. Well, you learned a little bit about what Fusion 360 is all about, and I'm planning on doing some tutorials on that. Please leave some comments whether you want to see tutorials on that or not. If that's something that interests you, I feel that it's real important to, if you're going to have a 3D printer, you got to be able to create your own files, and that's the way I'm going to be creating my own files, is through that software. And it takes very little. It takes some learning. I've been messing around with the software now for a little over a week, and not full time obviously, but I've been putting in a few hours. I probably have about 10-12 hours of drawing time in it now, and you saw how I was able to. Now I wasn't fast, I wasn't perfect, able to draw that little 90-degree camera mount piece in a short amount of time. But and the more you do, the faster you're going to get, and there's not going to be, before too long, there's not going to be too many things out there that I can't draw. So hope you guys found this informative and helpful and educational, and I hope you had fun. I had fun. I keep learning and growing and developing new things all the time. I want you guys to get out there and do the same, have some fun out there. This is Michael, and I'm out.